This is Geometry Lesson 2.1, and in this lesson we're going to talk about polygons. So a polygon is a closed figure that has straight sides. So I have three different polygons here. We're familiar with some of the basic ones already, usually like a triangle or a square or a pentagon, but it can be any shape as long as all of the sides are straight and it closes itself. So we wouldn't want to have like an X or something open like that. We wouldn't want to have a circle, but any closed figure with straight sides. The word equilateral means all of the sides are congruent. So I have three different equilateral polygons drawn: an equilateral triangle, an equilateral quadrilateral, and also an equilateral pentagon. Equiangular means congruent angles. So I have an equiangular triangle and an equiangular pentagon for my two examples there. The word regular is when a shape is both equilateral and equiangular. So that means all of the sides are congruent and all of the angles are congruent. A diagonal is a segment connecting two non-adjacent vertices in a polygon. So what that means is I can have a polygon, and I don't actually have it drawn on there, but if I have a polygon and I would draw a segment inside the polygon connecting two non-adjacent vertices, that is a diagonal. Here's a different diagonal over here, and I can have a diagonal right here, but I can also have a diagonal out here. Any 2 points that are not next to each other on the polygon getting connected, that's a diagonal. Our definition for concave and convex depends on that definition of diagonal. So concave means the polygon has at least one exterior diagonal. Sorry, I just noticed this. Okay, so here, because there'd be an exterior diagonal, this is concave. And so the word concave means that it has a cave. So anywhere where it goes in on itself, that is a concave polygon. A convex polygon means there's no exterior diagonals. So there's no caves in the shape. It's all of the corners kind of point outward. The last word I have on the definitions for this assignment is perimeter. Perimeter is the sum of the side lengths of the polygon. So the example here, I have a triangle with sides labeled 3, 4, and 5. The perimeter would be adding 3 plus 4 plus 5 to get 12. On the next page, I have a couple more that we're going to fill out. We have different types of polygons classified based on how many sides they have. So most everyone knows what a three-sided polygon is called. That is called a triangle. 4 sides, people are always tempted to say square, but a square is not an all-inclusive term because we can also have rectangles, rhombuses, parallelograms. So the word quadrilateral is all 4-sided polygons. 5 would be pentagon. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. And decagon. Undecagon. And dodecagon. There are more names for select polygons that have more sides than this, but it would be a little silly to just keep naming them. So anything higher than 12, we just call it an n-gon. So for example, if a shape had 15 sides, we would just say a 15-gon. The examples on the side here name and classify the figure. So the name of a polygon is when you list the vertices. And we want to go starting anywhere. You can go clockwise or counterclockwise, but you want to go in order. You don't want to jump around. So if I started here at J, I'd go to K, and then L, and then I, and that would finish off my polygon. So the name of this is JKLI. When I'm asked to classify, that means I want to say what type of polygon it is. This is a quadrilateral. I could get more specific, but we're not going to talk about that until later in this chapter, because it could be a square or a rectangle or parallelogram, but this type is quadrilateral because it has 4 sides. The next one, if I count my vertices or my sides, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10-sided shape, so we call 10-sided shapes decagons. The name of this decagon, again, would be to list the vertices in order without jumping around. So I would list A, B, C, D, E, F, G, H, I, J as the name of this decagon. Finally, I have polygons are congruent if and only if they have the exact same side lengths and angle measures. So which polygon is congruent to A, B, C, D, E? So I'm looking at this first polygon here, and I'm saying which of these 3 is congruent to the first. I want to look at every single piece of the polygon to see what matches up. And I'm going to eliminate this last one first of all, because I see I don't have the right angles marked that I have down on this figure. I'm going to eliminate this one because I don't have that bottom side congruent like I do on this figure. And I'm just double checking all of the angles of this polygon and all of the sides of this polygon. So my winner is polygon NMLQP. It is a pentagon, but I'm going to say in symbols then A, B, C, D, E. I'm going to get rid of this because it's kind of in my way. Is congruent to N, M, L, Q, P. So notice I started with N because the original one started with A, and then I went in order the same way without jumping around to different letters until I got back to the original. That's it for the notes for this lesson. You should be able to continue on to the exercises. Please let me know if you have any questions.